great that you're still around for our last workshop, talk, presentation, call it as you wish. And we're presenting SADISS, Acquire the Sound System. We are quite a few people, and we decided to just march them on, and you know. So this is Lukas Bindeus, Mathias Bindeus, Astrid, Schwarz, and Tobias Leibetseder. Many thanks. Yeah, and Volkmar, yeah, that's me. And we'll, you know, each part of that talk workshop will be presented by somebody else. And I will start. So, the plan is to introduce SADISS. You ask, SADISS, what is this? So, tell you, it's a socially aggregated, digitally integrated sound system, which should be kind of self-explanatory, might not be in a way. So we'll go into some details. It stems from an ongoing research project, Acquire the Sound System, which is funded by the Republic of Austria and the state of Upper Austria, which we are quite enthusiastic about. And the starting point was a conversation I had with Lukas, who quite a while ago studied composition with me for a very short time, really. But it was a very interesting conversation where he introduced me to web audio API, like the potential of doing audio within the internet browser environment. And the core idea was to create something that could re-synthesize sound files spread out through the audience's telephones. Not playback, but re-synthesize. And analysis, re-synthesis, we'll go into details. So we wanted to integrate the audience performance to really make use of them in a very immersive sound system engulfing sea of sound. No additional hardware needed, a PA-less system, and since it happens in the browser, no additional software needed, which is potentially wonderful, also troublesome, as we'll experience. But we've got 20 or 17 test telephones that are spread throughout the place, and it's starting already to encroach on you. Just to give you a first idea of how things might sound. Please do not doubt the artistic value of that. Obviously, it's a demo, and it doesn't stem from resynthesis, but just from synthesis. But still, to me, easily impressed as I am, it's quite cool. So, I'm just here to give you a very quick overview, and then details will be discussed by others. And also right from the start, spectral resynthesis in a very free-form way. You know, we are not worried about phase correlation, obviously. For if you're 20 meters apart, that's not even theory. That's just a past memory. So, there are two ways. We started from this resynthesis approach, and then we realized with the same technology, with the same approach, there are a lot of different things possible. One is the sound system, spectral resynthesis, synthesis. Synthesis, the latter you just heard. And then there's the choir version, where you could use as the Schallwandler, as the oscillator, the source of sound, a human person. You just play him or her or them a melody, and they sing along, they repeat things, you tell them, for we also added text-to-speech synthesis. You can tell people in different voices, in terms of choral voices, you know, you march to the left, you march to the right, and everybody sings, and so on. And this is now where the talk turns into a bit of a workshop, and for us into something scary as well, for it's time for you to integrate. We'd ask you to scan with your phones these QR codes you find everywhere. There are two different ones, it doesn't matter which. Please turn off auto lock in terms of the screen going to sleep functionality, and then scan the QR code, which will take you to our client. And we do understand that we are far from a finished product. One of the problems we also encountered, like a really big problem, is that latency in browsers is a random affair. Sometimes it's not a problem, quite often it is a problem, and also what browsers report back is not necessarily correct at all. So we've got a very dirty hack for that. We've got these 4 stations that go beep, beep, beep. That's the master time. Once you are registered with our system and you have click play, your phone will start beeping as well. Then please walk over to one of these computers, little booths, the synchronization booths for the onboarding process, and we'll assist you. Yeah. So.
And please take some headphones from connecting.
Yeah, connect headphones if you've got some. If you haven't got, we've got headphones for you to connect. And if you are on a headphone plug free phone, just turn it quiet over to your phone, I guess. To your ear. Sorry. Okay. So let's get you on board.
Nowadays, it's the Apple story with it. That's right. Okay, got it. Stop. Okay, got it. Now that it's on sync, yeah. I don't need to have it. Yeah. Okay.
Okay. Yeah, I was far away from the.
Yeah. How many phones are we connected? 38. 38. Sounds like, yeah. And whoever doesn't hear anything, sorry for that. Yeah, we were working hard. Okay, we're playing.
Hi. Welcome to the performance. We tie ourselves with visible features and community. This we enjoy greatly. Many thanks for joining our communal effort. I will help guide you through the performance by narrating and commenting what is going on around you. From time to time I will even Instructions will either start with action followed by a short description like raise your right arm slowly or please speak, followed by the word or sentence we would ask you to speak at this moment. Just to make sure we got this sorted, may I suggest we try it out once. Action. Raise your right arm slowly. Well done. Now, say out loud. I am never quite sure where right and left is.
I'm never quite sure where left and right is. So true.
Thanks. This works surprisingly well. Okay, so let's try something else now. Would you mind doing a bit of singing for me? Actually, not really singing, humming would be wonderful already. I will play you a melody and it would be great. Could you, in your own time, join in, simply by humming along? You will see, or rather hear some of the other people around joining in, too. Some of them humming harmonies to your tune. Not all of them, we only asked the ones we thought might be good singers. How would we know, you ask? Well, it is true that we hardly know each other, but you know phones know things, so I am quite confident it will work out just fine. Don't worry too much about the other singers, just follow the tune I will play to you. You can hear it fade in the background already. It is quite short, and it repeats, so I guess you won't have any problems. Whenever you feel comfortable, just join in and hum along.
Many thanks for singing. This really was the first time we tried this in real life, so I'm sure it didn't work for everybody, but it was. I'm touched. That's good. What I forgot to mention is you could have selected German as well as a language, so it's also an international tool of control. So we've got coming up Lukas Bindeus on the tech background, Astrid Schwarz on how to come up with a SADISS track from audio, Isabella on how to get there from MIDI, Tobias filling you in on the choir mode, including text-to-speech synthesis. I'll return to, for the issues, further development options, Q&A. So, Lukas, please.
Hello, I'm Lukas, I'm a software developer. I used to study here for quite a while, so I've got some musical background, but mostly what I'm doing at the time is programming things like this. I will quickly talk to you about the technological background of this. For programmers and technicians it's going to be somewhat interesting, for all the others it's probably a bit boring, so you can give me some signs of response if you want me to go over it more quickly or more slowly. So, what we're using here is a traditional model in web architecture. It's called the client-server model, and it's what all web applications are using, what Facebook or whatever is using. We have a server, and we have clients. And the server and the clients are communicating bidirectionally. So our SADISS app is running on the server, and when you scan the QR code or visit the URL, then you download an executable piece of code onto your phone. And this executable piece of code, the client, is then following the orders of the server. So what you've been hearing is it's talking to you, or it's synthesizing sound. There's also a performance interface on which Tobias, we're sitting here, which controls the client, so which gives signals over the internet to the server, and then the server renders the signals to the clients again. So all of this is connected on the internet. So there is no, it's not in a Wi-Fi environment or anything. This could theoretically work in any setting, on a huge demonstration, in a football stadium, whatever you would like to use. Everybody's got their phones, everybody's connected to the internet. Of course, as you know now, there are lots of different phones and all kinds of technical problems, but theoretically, it's like this. We have a time source, which ensures that everything is in sync. And also this, as you see in the booth, it doesn't really work 100%, but it's getting there. What we, Volkmar and I, didn't know when we were talking about this, we had the specification, you know, and it was theoretically possible, but in reality this does not yet work as well as we've expected it to. This is cutting edge, state-of-the-art, top-notch with development. So we're using different frameworks for this, but the frameworks that we're using are the same that most modern web applications are using. So this is written in PHP and JavaScript. That's two languages that are very common on the internet. And we use Laravel and Vue.js, which are backend and front-end frameworks, and something that's called the HTML5 Web Audio API. And the Web Audio API is a system that allows your browser to make music. So Web Audio API is not just playing a sound file, but it can actually play a sound file in your browser, and you can modify the sound file, you put effects on it, you can slice it up, and you can reverse it or whatever. You can add synthesizers on it, software synthesizer to play the sound that you tell them to. This is a very simple example. In 6 lines, you can create on your browser, and it works on every browser, just create a software synthesizer, and then you can give it instructions on how to work with it. I'll quickly go over this, just in case you want to experiment with this, but if you use just the 6 lines, then you can make music with your phones, so you don't need to learn an instrument anymore, you can just start teching. You create an audio context, which is the base of everything that happens in it, and then you create on top of this audio context an oscillator. You give it a waveform to work with, in this case a sine wave, and you tell it a certain frequency on which you would like to produce the sound wave for. And as soon as you start to connect this to your audio context, what's going to happen is that your phone or your browser will play a continuous annoying sine wave. But you can use all kinds of programmatic methods to change the oscillator type, the volume, the frequency value, and this is what we've been doing. So the server sends to the client a list of different frequencies and time breakpoints, on base of which the phone decides which frequency to synthesize. So this works now in all major browsers, which is nice because 2 years ago most of these fields were red. Now just Internet Explorer, which is obsolete anyway, is red, and on all the other browsers in their current versions, this works just fine. The problems that we have are more with synchronization or with other problems. Just the iPhone, for example, likes to just randomly switch itself off at any point in time, but the web audio thinks that is the base and the heart of the application that works just fine. We've published this code onto GitHub, which is a public platform for open source software, and we've licensed it in a copyleft license. And this is quite important for us because it means that you can now go and download this and use this on your web browser or locally in your environment. And we would like to invite everybody who is interested in these systems to do so. You can just take the client and server code from this repository. There's a link here, but there's also a link on our website, or maybe soon there will be a link on our website.
There is now.
There is now, great. You can just download it, and the GitHub repository also gives some instructions on how to set this up for yourself. So you will be able to control people in your personal environment if you like to. We will be helpful with this, so if you want to do something on base of this, then you can just get in touch with us. And we will also continue working on this, so you can just, with this environment, just talk to us and give us some hints or fix some bugs for us. That would be nice. So we invite everybody to participate in the development of SADISS either as an artist or as a programmer with your album.
So is there a possibility to get the slides later? Or?
I think so.
We'll put them up on our website.
Okay.
Exactly. So that's it. If you have technical questions, we'll be, of course, answering them later.
So now you heard the technical background, and I'm going to be covering like how to work with audio files in SADISS. As you already heard, SADISS is not playing back like whole audio files to your phones, but only segments and parts of audio files. And these segments and parts of audio files are called partials. A partial is a small segment of a very complex sound, and each partial has a duration, a frequency, and an amplitude. And if you stack them above each other and behind each other, you get the complex sound picture, kind of. And so we want to get this information of these partials to the phones. So we have to change from the WAV files or IFF files to text files. How do we do that? First, we analyze the files and split it into partials. Then we filter and extract relevant audio information in order not to overwhelm our still a little bit weak system. And then we export data into the text formats, kind of translation from WAV into text file. And then we are ready to resynthesize the information, the data on the phones. So there's different programs available that work with spectrograms and spectral informations. We chose Spare. It's not open source, but it's you can download it freely. And if you open a sound file in Spare, it looks like this. You get all the partials displayed on the screen. Like the darker ones are the louder ones, the shallow gray ones are the ones with low amplitude. So the strength of color is the amplitude, the length is the duration in seconds, and the y-axis is the frequency. So, as you see on the left side, there's lots of like small partials, lots of information. It is actually not really necessary to get a picture, to get an idea of the sound you want to display on the phones. So you just delete all the unnecessary information, and then you get a much more slimmer partial file that kind of is appropriate for our system. Our system can handle it. So I'm going to play you now an original audio file and then the filtered part. Now the filtered one. So you heard, like, the information is still there, but all the noises, the small crackles are kind of vanished, but you still get the idea of the sound. That's what we wanted, actually. So we exported now a text file, and that's what you get. You get on top the partials count, that's the number of the partials that is contained in your music file, and the partials data, which is like numbered from 0 to, in this case, 689. And the partials data is composed by time, like the beginning and the end of the partial, the frequency, and the amplitude for each partial. So now you get everything to upload it to the server, because the server is distributing these partials automatically to the number of phones that are registered, like we heard here before. So to set up a performance or to play back your sound file, you log on to the SADISS server via the browser. There's this add button, then you get this picture kind of popping up. You just fill in the form, submit, and most probably you get a success button, which means that it is on the server and you can start setting up a performance. Here you see you can add your track on the right hand side with the plus. Then you select the waveform, either a sine wave, a square wave, or a sawtooth or a triangle. Then here you see the registered clients, and here then a playback button appears. So you're ready to play. So if your phones are still plugged to headphones, please unplug them because we're going to hear now this file from before on the phones that are registered.
So I will be short and pregnant. Another way to set up the sound system is via MIDI. Essentially, in any DAW, which allows to export a multi-track MIDI file, also known as Type 1. You need to insert just a track and export the MIDI as a Type 1. And with, as you can see, for example, here, our workflow is we use essentially Logic, but also Reaper to make the process, the project as accessible as possible. After saving this MIDI file, you can drop the file on this MaxMSP patch developed by Volkmar Klien. Essentially, you drop the file. And what is interesting here is that you can assign ADSR to every note event. With MIDI, of course, you don't have this kind of information. So you can do that. And after that, make sure to save the file as of course a test file, and the text file is gonna be the same. It's gonna look exactly as the one that Astrid showed before. And here, of course, the advantage to work with MIDI is that in the end, even though you have complex MIDI files, still you don't have much partials. So with a fragile system, you still the MIDI option is a sustainable way to go. So and now, of course, what you're going to see then next with Tobias, the MIDI is going to be an important element to set up the choir mode. I would like now to listen with you briefly an example so that you have at least an idea. Tobias, please.
Quite a lot of SADISS now. So I may now introduce you to the what we call the choir mode, and it's furthermore as we have done. Yes. As we have all participated in this piece where we have sung along together, and this was also part of this mode, of this choir mode. And just in the first place to take a summary resolution, so choir mode offers a wide range of possibilities. So let's think about creating a huge mass of voices singing together, instantaneous, and a participative performance, so, or sending text messages with instructions to a mass of people in a stadium, just to creating some sort of immersive events together. And yeah, you can think of many more options that this kind of mode provides. It works a little different to what we've heard about the sound system mode, with this partial system getting provided throughout all the spectrums to all these different clients that are this kind of speakers. In this kind of mode, the human body and the human voice will get the resynthesis mode that we then offer, and it's much more immersive than in a kind of way to participate in this way. So let's dive a little bit deeper into to use this mode. We have to think it a little bit different, because all the partials we heard before in this sound system mode that are then extracted to all the clients need to be now registered to certain devices to offer a certain voice like a choir would have. So for this example, there's a 4-voice setting, as it would be done standing 4 people in a row, maybe, just as you know in the church or something somewhere else. So, as you try to sing along with this sounds you heard, each client, in this case a mobile phone, has to be connected to a certain voice, and that's what we do here. These voices are consisting of the partials that we heard before, but this is just a method. So it's working like this system before, but it's connected to some specific client. So that's the difference mainly. And also there's a difference in setting up the file, because the partials that we see here count 4. So it has to be then that for the certain voices you need to use in your choir performance, the partials are fitting. So then you have 4 voices and 4 partials, as we've seen before, just to connect the clients. Therefore, this file has to be created in a certain way. So if you see, and also to get the clients connected to all those different voices, we also choose to use QR codes, as we did with. Is it quite a difference to the sound system mode, where you can connect to a whole performance, and this is the thing. But if you have a setup with 4 voices, for example, then each of the voices gets its own barcode with all the information contained within, so that you can connect and register to this certain specific performance. To create musical content is like we have heard before with this MIDI functionality. So yes, you create a MIDI voice, for example, you can listen to also in your DAW or Reaper or something else, and then you have to export it with a certain format 1 and drop it to this max patch we've seen before, and that's basically it. The next part we're stepping into is the text-to-speech integration, which offers also a kind of internationalization. So we were able to provide text messages through the text-to-speech functionality via JSON. This is a file format we use in this case. And it offers the possibility to create certain text messages to specific timestamps. So that's how it basically works. And the 2 modes, one is also possible to use this without this kind of choir settings. So there's no connecting of specific clients to specific voices, just to have maybe connect to a mass of people and sending one message to everyone, giving instructions to dance, or I don't know, just yeah, let your imagination fly, you know. And there's you can see in this, it's just one example to see how it works. 0 and 2 stands for the timestamp. It's 0 seconds and 2 seconds, and at a certain point, this text will be provided in English or German or any other language you want to specify, and you can just select this within the client or the browser then from your device. For doing the same in choir style, so you wanted to send different messages to different clients, the file format will be a little bit different, so that there's another layer at a given timestamp. Then you have these indices that refer to certain voices, so you can then send different texts at the same time to different clients. So then everyone has another instruction, maybe to raise your arm or to stretch your leg, or yeah, or you could do a theatrical plays with it. So yeah, everything is possible. To set up a choir performance is also very similar to setting up a sound system performance. The only difference is really to upload also, if you like, to integrate text-to-speech option, then to also send it to the server with this TTS file upload function. And if it is a choir piece, then you have to obviously switch it on. So, but it's quite easy. And yes, then let's listen also to the example how this can sound, just real simple.
Two. 2. 2. 2. 2. 2. 2. 2. 2. 2. Thank you for your participation.
Okay, thank you. Now focusing on the divisions.
Yeah, so just to round things off, yeah, one device is a bit late. Yeah, so what are the issues we encountered? What are ideas for further development? Having everything run in the browser is brilliant, for you don't need an app. Being locked into a browser with all the limitations is difficult, so this is something that we'll reconsider, how we'll deal with that. Pulling it into an app isn't all that much of an issue, but it will always come with trade-offs. Synchronization at the moment, we are using a Norwegian company that is called
Motion Corporation.
Motion Corporation, that helps us out with synchronizing the devices. So many thanks to them, but also this is something we want to incorporate in our own system. Latency in web audio is a bit of an unknown beast, a dark horse. For many compositions or theatrical approaches, it's fine as it is. If somebody is like 100 milliseconds behind, it's not a problem. It's a lot if you want to have a kind of tight technique beat. Then again, if you're a big crowd, sound doesn't travel as fast as light, so if it's 3 meters away, you are into like 10 milliseconds already of delay, something like that, like 334 meters per second it is. So that's an issue. Also the workflow, a bit rickety at the moment. It works, which is good, but of course it would be nice to integrate that more fully. So Yeah. Spare is closed source, editing JSON files manually, horrific. MIDI to partial, the thing I hacked up, also pretty grotty, but otherwise it's actually working quite well within all its limitations.